Perfect. The thing that we're going to discuss in today's class is all about automation or an introduction to automation and programmability. It's kind of a small topic, I would say, but yeah, an important one to discuss. So, to start up, the game, or I would say the trend of automation has been there for quite around an year now. And there has been talks and there has been discussions, and everyone is pretty curious inside the production environment to learn about automation. In fact, if I talk about my experience with automation, then I have kind of built up my I would say specialization in automation since 1.5 years now. And I started learning about automation and how it can be deployed into the production environment. Soon as Cisco did the announcement that they're coming up with something called the DevNet certified tracks. So they have these DevNet certified associate trainings and DevNet certified professional trainings now. However, there is no expert training as of now, like we have CCIE for other tracks. So there is no CCIE for the DevNet track, but yeah, they do have an associate course and a professional course. And soon as they announced about the automation, the industry was kind of moving towards the automation itself. Now, what actually happened is there is a concept or there is a technology or a platform called SDN, and I believe everyone must be familiar with this. SDN stands for Software Defined Network, right? Software Defined Networks. Now, what this software defined network means, there are so many meanings to it, I would say. You can take one meaning of software defined network to configure your network devices by using software, or you can say that by using controllers or by using some other type of method. What usually happens if we talk about SDN is SDN was kind of a technology that was came into being in order to create a better packet forwarding techniques. Meaning, if you want to forward traffic from one direction to other direction, then the packet forwarding technique that we really use are routing protocols. And we use OSPF, we use EIGRP, or we can even use RIP, or we can even use static routing as well. So when we use such technologies, then these technologies work according to some planes that are present in on each and every device there. So if we talk about each and every device, let it be router or a switch or a firewall or something else, every device has some planes with it. And you have management plane, then you have control plane, and third is you have data plane. Okay, you have management plane, you have, I would say, control plane, and you have data plane. And you would find these, I would say, the planes like management plane or control plane or data plane in each of the Cisco's device. So the management plane in Cisco basically, you would say, provides the capability to restrict the interfaces on which the network management packets are allowed to enter, right? And if we talk about like this such kind of planes, then every device do have such planes with it. So whenever you actually want to communicate by using a PC to a router, then you can either connect with that particular device by using telnet or by using SSH. And the medium that you are using this, you are actually consuming something called management plane of that specific device. Okay, you are configuring that device by playing with the or by connecting with the device by using the management plane. Then what does control plane do? Okay, there is another thing called control plane. So the, I would say, control plane on networking devices is something like kind of intelligent logic of what is running on those devices. and with what intelligence, like protocols like OSPF, EIGRP, RIP, and so if you say that you are configuring OSPF on this particular device by using telnet SSH. So you are using management plane in order to connect with that device, but then you are provisioning the control plane of that particular device. You are telling that particular router that how the communication should be done, and you are saying that use OSPF for doing the configuration. And then whatever I would say algorithm OSPF is going to use, it's consuming nothing but the control plane of that particular device. It means that you are kind of using the control plane of that device in order to figure out that how data should be forwarded. And then the data or the routing table, meaning that the data plane is only responsible for forwarding traffic. So the traffic which is getting inserted into something called routing information base, or I would say forwarding information base. These two are nothing but your routing table. Okay, so this RIB and FIB information based is based on the control plane direction. Okay, and then control plane kind of gives the information to the data plane, and data plane builds up the routing table according to the information that is being given by the control plane. Okay, because control plane will do its task, and then it will figure out that this is the best route, and then same information will be given to the data plane, and then data plane will forward the traffic based on the information that it's using. So do you understand all these three planes? Make sense to you? Perfect. Now, when we talk about going back to the software-defined networking, what used to happen over here is if you have a topology like let's say you have R1, you have R2, and you have R3, and then you have certain switches as well. Yeah, so what we were talking about is whenever you are going to see the topology like this, that you are going to have multiple devices, and all those devices can be configured by using a management PC. And then this particular management PC is going to reach out to each and every device by either using SSH like this or by using Telnet. Okay, and then by using such kind of methodologies, you are consuming the management plane of each and every device, because every device has management plane, control plane, data plane, management plane, control plane, and data plane, right? What software defined networking specifies over here is whenever you use SDN, then SDN is no longer focuses on how packet forwarding technique needs to be improvised. Okay, because that is what the initial motive was of SDN, in order to improvise or in order to improve the methods or techniques of how packet forwarding is done. But then later on, they kind of discovered that the need of, I would say, production is into network operations, meaning they came to know that the original, or I would say that the actual need of the network was to make the network operations better. than improving the packet forwarding techniques, because OSPF and EIGRP and BGP are working at its level with the best capacity, and they are bringing out the results as well. What we actually need to focus on is how you actually configure the devices if you have more than certain devices in your network. So that's what you needed to focus on. And then after that, what happened is SDN came up, and then SDN started to do kind of a bigger task over here, which was to decouple control plane or control and data plane. You get that? Decouple control and data plane. This is actually what was done. Or this is actually, I would say, what has been done. So now, what happened by using SDM is every device had its own control plane and data plane, control plane and data plane, control plane and data plane. But then the routers or the switches that are situated over here will just retain data plane locally, and then control plane will be given to the management PC, meaning that configurations of RIP, EIGRP, OSPF, or any type of configuration will be done onto control plane that is on management PC, and then same information will be carried forward to each and every device by using the management plane, either via SSH or either via telnet. Do you understand what I'm talking about? So SDM is all about decoupling control plane and data plane. Okay. And then controlling or configuring your device by using a centralized machine or centralized system. Do you understand this? Perfect. Now, what happens over here is there are different platforms that are available in order to do the config and so. Okay, so if we talk about the configuration, then so usually we have iOS devices, correct? Then you have some other devices as well, like let's say iOS XE, and then you have ASAOS, you have NXOS, you have iOS XR, okay, and then you have as devices like SD-WAN, or I would say platforms like ACI, application centric infrastructure. These are all the advanced, I would say, platforms. So far we have just worked with iOS devices, and iOS devices just supports telnet or SSH in order to be configured on those devices. Okay, iOS XE, ASAOS, NXOS, and all these do have the ability of configuring the devices by either using NetConf or RESTConf, or purely using REST API. Make sense to you? And what these protocols are, we call these as programmability options, okay, or APIs. And what this API stands for, API means application, I would say, API stands for application programmatic interface. Sorry about my handwriting. Yeah. So this is what API means, and what this API does for us. So usually what we have been looking at is if a router is situated over there and we want to config OSPF, what we would do, we would say router OSPF process ID, let's say 100, and then network this and network that. What this would be, these would be CLI commands. And whenever we kind of send these commands onto this device by using SSH, let's say, then the device can figure out a way in order to understand what the user is prompting by using these commands. correct? Meaning that the device has the ability in order to get configured by using this. Then when different platforms came into being like ASA and like iOS XE, Cisco started to offer you an option to configure this device by using GUI, and GUI stands for graphical user interface. So let's say you purchased a firewall and that firewall needs to be configured. Now the option to configure the firewall was either go through CLI config or use a UI that is called as Application Security Device Manager, ASDM. So you can install your ASDM onto this management PC, and then the management PC can open the ASDM, connect with the device, and do the configuration by using the GUI. Do you understand that? So these were kind of the two of the most popular methods that were getting famous back then. Okay, but using GUI again had a limitation, that how many devices would you be able to configure by using GUI? That would still be one device at a time. However, what happens now over here is API is something that if you do or deploy the configuration by using ASDM, then you are using UI, right? User interface. And after using this user interface, you are not actually typing the commands that the device is expecting. The device expects the language of the configuration to be somewhat that it can understand. So APIs does the job of converting your configuration into a device understandable configuration. Okay, it acts as an interface between your computer and the device, and it translates the languages or it translates the content that you share with the device. Do you understand what API means? As I told you? Great. Then, if we talk about something like, let's say, that the device now needs to be configured. So after reaching out to GUI, and we are talking about evolution that is being done from like 2000s and so till 2010 and so. What happened? This wasn't even enough for SDN, okay? Because the limitation was still that you can only configure one device at a time. And networks over here wanted to improve their performance, that we should be able to configure multiple devices by using, I would say, a single source of configuration. So over here, what happened was then in 2002, there was kind of a workshop that was held by IETF. So in 2001, I would say, IETF kind of held a workshop, and the discussion, or I would say people from Cisco and Juniper and CCNA, Huawei, Google, Oracle, and so on. So all the like top companies people were invited in that particular workshop. And then the discussion was done about how device configuration can be improvised. Because back then, there was a protocol called SNMP, and SNMP still exists today as well. But this was the only smart protocol that was available in order to configure device. Again, this protocol didn't leverage the options to configure multiple devices from single, I would say, point. Okay. So for such a thing, industry kind of wanted that there should be a protocol that can actually configure multiple devices at a time. So, in order to find up better options, the I would say workshop was kind of conducted, and then the people kind of came up with two solutions. Okay, in order to have a better option than SNMP to configure network. So one came up as NetConf, okay, and the other one came up as Yang. And NetConf came up in 2006 and Yang came up in 2010. And then there is another protocol called RESTCONF. that came up in 2017. And what these protocol do? These protocol gives you an option to configure multiple devices at a time by using, I would say, Python. So Python became kind of a thing. Okay. And then there is two options. You have on box programmability and you have off box programmability. Okay, you have on-box programmability and you have off-box. What do you mean by on-box programmability? On-box programmability means that you can actually send your Python script directly onto the device, and you can run your Python script on the device itself inside the command line interface without the need of a centralized device. And off-box programmability means that you can use different third-party tools in order to configure multiple devices at a time smartly. Okay, and as of now, we have been using off-box programmability itself for configuring multiple things. But what happens is there are two type of bonds. So you have northbound, okay, and you have southbound. Southbound is basically connected to the devices. You can say routers or switches or firewalls. All these devices are connected to southbound. And then northbound is connected with applications like Postman, like Python, okay, or some other APIs also. So what happens? Of course, you're not going to write down the configuration into CLI language, okay, when you are using these third-party applications. So in whatever language you're going to use this configuration, the northbound is going to receive that config and it's going to send that config to the southbound so that it can be configured onto devices. But the language then needs to be interpreted into an understandable language. And for that, REST API, okay, or APIs does the task of configuring such, I would say, context to the device understandable viewpoint. Do you understand what I'm trying here? Yeah, so that is exactly what is happening. Okay, now the device then receives the configuration in some other form and then it can be configured over here. So what are we going to do over here? This is kind of an intro about how automation is kind of coming up. Now, what are we going to see over here is we will be able to see an example of how off-box programming is done on network devices. So we are going to use a simulator software that is GNS3. And in this GNS3, we are going to have a router and then we're going to connect that particular router with a management PC that will be our PC itself. And then we're going to write down the CLI configuration into the Python. And then we can deploy that particular configuration onto multiple devices. Okay. Yeah, Nikhil is asking that future scope of automation. There is a huge scope of automation. Even Cisco itself is recruiting a lot of people inside for automation, and only network automation is going to survive in future. So it's the best time because if you talk about normal network engineers, then like there are so many network engineers that are available as of now, but there are very few network automation engineers that the industry is looking forward to. So this is the correct time to start your career and jump into over here. Yeah, you can do the lab on GNS3 and you can do the lab on Eve NG as well. So let me share my other screen. I'll show you how automation can be configured. Now, this is not a lab that you probably would be able to do. I don't think so. But if you have GNS3 already installed, then you can do this lab. But just first look at, I would say, this lab. I'll just create a name for the project as sample. And then I'm going to create a topology. I'll go to this router section and I'll just take this 3745 router. Then I'll take a non-manageable switch from switch section. And let's say that this is a non-manageable switch. Okay, and I'll connect it with my VM server. Then I'll take another appliance that is going to be the cloud appliance, and I will again connect it with my VM server and store it over here. And then I will make the connections. So I'll have this FA0/0 connected with Ethernet 0 and Ethernet 1 connected with the Ethernet 0 of this. If you don't, this asks for the password of my Mac. Cool. Then if you don't see the names of the interfaces over here, you can just use this ABC tag and then you will be able to see the names of the interface. There you go. Then we will start our device by right clicking on it and say start. You need to start every individual device in GNS3 separately and then you will be able to get the CLI of this. So this is our physical command line interface or terminal, I would say. And then you have this interface over here, which is our R1. The interface or the router is booting up. Now, what is happening over here is the DSCP server on this Ethernet 0 cloud has already been connected or created by this VMware. Okay, and it's going to get the IP address of 150 subnet onto FA0/0 interface, which is actually bridged with the physical interface of our Mac as well. Okay, so I'm going to access my CLI of R1. You see that? And then you can say that I can go to conft and say interface FA0/0, and then I would say no shutdown and IP address DHCP. I'm trying to get the IP address by using DHCP over here. And as I hit enter, I'll just wait for a couple of seconds and I should get an IP address via DHCP. There you go. I just got an address on my FA0/0 interface that is of this 192.168.150.132. I'll make a note of that over here and say 192.168.150.132 is an IP address over here. Okay. Now the magic is that I can actually go to the physical terminal and I can ping to the virtual interface or virtual router that is present inside my GNS3 from my physical machine. Do you see that? I can actually ping to this router from my physical machine. Do you understand what is happening over here? So this is actually what is kind of working over here. Now we are going to write down a Python script on our physical machine on my Mac, and then we are going to run it against this router that is present in the GNS3. And how do we do that? I will use an IDE which is called as VS Code, and I will kind of write down a code over here. So this is what our topology looks like actually. And then I'm going to write down a script in Python. Now we are going to access this particular router by using telnet. So we need to make sure that telnet is also on this particular router. So I'll just go on to my CLI of R1 and I'm going to create a username password combination for this by using enable password as Cisco and by using username admin and password Cisco over here. And then I can take an exit and then go to conft and say line VTY 0 space 4 login local and take an exit. Do you understand what is happening? I created some username password combinations and then I turned on telnet access on our R1. So I can actually check it over here as well that if I try to telnet to the same IP address on the router that 132, Then it has asked me for the username, and the username is admin. The password is Cisco, and there you go. I am inside of the R1. So the R1 can now accept the telnet request, right? Now this was the only minimum configuration that we require onto the device. Then I will go on my VS Code and I will create a new script. You can see that Python is installed. We are using Python 2.7 here. And I can say that create a new script. This is kind of a new script with the name of untitled one. And I will save it as, let's say, r1.py, and .py is an extension that we use for our Python scripts. So I will save it over here, and you can see that it is a Python file. Do you understand till here? We're not using Python 3 because, so I also have Python 3 installed. It's not the thing. You can see that Python 3 is also installed. But Python 2 is easy than Python 3. So I'm just using Python 2 for this demonstration. Okay, and then we are going to write up a script by importing the telnet library. We will say import telnet lib, and then we are saying import get pass. Get pass is a function that we kind of import in order to accept password from the user. So we will create some of the variables over here, and those variables will be host, or I would say target. And what is going to be our target? The target is 192.168.150.132, the IP address of our R1. Then we are going to say what is the username. The username over here is admin, right? We don't really need, I would say, get pass. And then the password is Cisco that we are using. And then we are going to create a variable that says tn is equal to, okay, the variable tn will refer to the telnet connection. So we are using this particular module, which is telnet lib, and of that module we need to use a function or a class called telnet. So we are saying telnet lib dot telnet, and then we are saying with which device do we want to create a telnet connection, and that device detail is stored into a variable called target. So telnet connection will be established against this target, and the target contains information of the IP address. Do you understand till here? Any questions? Perfect. Then after using or after hitting this command, what is going to happen is we are basically using this thing, okay? And as we write kind of enter this, what happens? The device prompts for the username thing. So we are going to specify in our script that until unless you get this prompt, the username prompt, wait for that. Okay. So once we use this command, just wait for username to be prompted. And for that, we are going to specify tn dot read underscore until. We will say read until you get a message that looks like this, username, colon and space. Okay, so when you get this particular message, then reply to that. Okay, and what should be the reply? The reply should be the variable username, and this is the variable username. What detail do we have in that? Admin. So automatically admin will be given as a reply to this particular prompt. Plus we also need to hit the enter button, so we will concatenate that by using a slash n character, and slash n means new line inside coding language. And then we're going to do the same thing for password, but we will first check if password is stored. And if we have password, then we are going to run the same thing, that tn dot read underscore until. If you get a prompt for password, then tn dot write with password plus new line, and then this is going to complete or create a telnet connection. So the script will hit admin, and then the script will hit password as Cisco, and then the telnet connection will be established. Okay. Okay, sorry about that. It's right. Yeah, and then we are going to specify our commands by using tn.write. So the first command inside the CLI will be enable, and we need to use slash n after each and every command inside the same line, so that the enter button gets also sent via the script to the device. And then the next command, or I would say after we hit enable, we also need to enter the password, that is Cisco enable password. And then we will go to the conf t mode, that is going to be configure terminal slash n, and then we say tn dot write and say interface. Let's say we are creating a loopback interface 10, and then we are giving an IP address to it by using IP address command 192.168.1.1.255.255.255.0 slash n. And that is the only configuration that we will do. So we will say end here, tn.write end slash n, and then tn.write exit, and exit will break the telnet session. So this is going to be our script, and then we will say print tn.read underscore all. So it's gonna read everything that is going to be printed out. Okay, makes sense. This is what our script looks like. Okay, and the output of this particular script should be that there should be a loopback interface that should be created. So if I say show IP interface brief now, there is no loopback that is present, right? These are the list of interface that you have. And then you can kind of run this script, run Python file in terminal, and you can see, there you go. It got the R1, enable, password was entered, configure terminal, interface loopback 10, IP address and end, and then exit. These were the commands that was entered. And then you can see that show IP interface brief. And there you go. A loopback interface 10 has been created by not accessing that particular CLI of the router. Do you understand that? How this is actually working? Makes sense to you guys? Let's say we want to create some other, I would say, loopback. We will create 20 and we will change the IP address of 10.1.1.1 and save that particular script and run it. Run Python file in terminal. And it is also done. And you can just go ahead and check it again. And you can see that loopback 20 also has been created. And just like that, by using the ability of Python, you can configure multiple devices at a time. Okay, and can deploy multiple set of configuration on routers, on switches, or on any device that you want by using different libraries. This is kind of a very basic example that we have used for our telnet. Okay, but you can use other examples as well. Okay, you can configure SSH and you can configure some other things as well. So that was what we had to discuss about automation and how automation actually works. Okay, this is a very basic thing, but yeah, this is actually how it works. So I hope it has made kind of a sense to you and you kind of got an idea that how automation works over here. There are so many other things as well that comes apart in automation, but there are dedicated courses for that. Yeah, if you have, Yap is asking that if a new config is done in Python, it would override the previous command. Yeah, it will override the previous command. Okay, so if you already have, let's say, the loopback interface has been configured with 10.1.1.1, right, for 20. So I'll just run the command again and change the IP address to 20.0 or 21.1.1. Okay, so I changed my script and I will again run it. And there you go, it has been configured. Now, if I go ahead and run this show IP interface brief, then you can see that the IP of loopback 20 has been changed to 20. So it can override your existing command. Okay, you can visit the website of python.org in order to get to know about the libraries. Okay, right? You can visit the official website and you can get the documentation for each and every libraries that are there. The configuration of loopback 10. Oh yeah, so your configuration, once you deploy this particular script, then the configuration is sent onto the router. Then you don't need to use the same thing again and mention each and everything inside your single script. You can use 10 different scripts for deploying certain part of configurations, and that will be configured onto the router step by step. There is nothing that you should configure a script that includes each and every configuration. Okay, you can use a script for loopback 10, you can use different script for SE2/0 and so on. So yeah, cool. I would say that, so that was, I would say, the content that I had to cover in today's session. Okay, there is not much thing that Cisco highlights about automation, and even this lab is also not there into the official curriculum. But I kind of showed you that how this can be. Yeah, this is Microsoft Visual Studio, and we are going to have a dedicated training on such kind of things. This is like, I would say, 2% of what we're going to see in our upcoming training, that is about Python for, or I would say network automation training, that is going to start from 14th of December. Okay, and it will be focusing more and more on how you can configure platforms like normal iOS devices, iOS XE, ASA, iOS XR. Okay, and then you will get a glimpse of ACI and all. We're going to see all this platform configuration, including Nexus switches as well, by using multiple sort of things like using telnet, using SSH, using NETCONF, using RESTCONF, using REST API. Okay, and using model driven programmability, Ansible. Okay, and each and everything will be discussed in that particular training. So that is what we are going to have our training dedicated on, which is going to start from 14th of December, using Python 3, of course. Okay, Python 2.7 is going to expire on January 2021, so you won't have any support for Python 2. So we're going to start our training with Python 3 itself. However, we'll discuss about Python 2 and all there and see the comparisons. But yeah, the labs are going to be done on Python 3 itself. And then you'll get the lab setups as well, that how you can install those labs, and installation guides will be provided, and the demo session will be provided, installations in it, and you can use the systems over there. So as it's going to be a paid session, you will get kind of a lot more support over there. Okay, and a real time troubleshooting will also be there. And for the same reason, we are not admitting more than, I would say, 30 candidates over there, because we need to be able to, I would say, resolve the issue of each and every candidate there, as it's going to be a paid session. So yeah, that is what our focus is. And I would like to thank you so very much to each and everyone in this particular training, okay, for attending this training. I hope, if not 100%, but 60% of content would have been entertaining for you, and that would help you in your career in order to build up a kind of a strong career. So yeah, thank you so very much, each and every one of you, for attending this particular training, and we are looking forward to see each one of you in the future as well.